So we are going to learn about some parallel lines and a transversal and the angles that are formed from those. So we already have talked about two very special angle pairs. What are the ones that have continued to come up over and over that we've talked about that are special angle pairs? One starts with a V. Vertical angles, that's one of our special angle pairs, and linear pairs. We're going to learn some more special angle pairs over the next several days, and we'll talk about their relationships to each other. So vertical angles, the relationship that vertical angles have to each other is that they are congruent, so they have equal measurements. And the relationship that linear pair angles have to each other is that they are supplementary. They add to 180 degrees. Our new special angle pairs are going to have one of those two relationships. They'll either be congruent or they will add to 180. All right, but let's start talking about parallel lines. If two lines do not intersect, then they are either parallel or skew. So parallel lines are coplanar lines that do not intersect. This notation right here in between these two lines, that means parallel. This is the parallel lines notation. Parallel lines notation. Looks like two lowercase l's side by side. Skew lines, on the other hand, do not intersect, but they are not coplanar. They are not in the same plane. So here's a picture of two planes, one above the other. Plane A is above plane B. Plane A has a line L that's going back and forth from the lower left corner to the upper right corner. Plane B has a line that goes back and forth from the upper left corner to the lower right corner. These two lines do not intersect, but they are not parallel. They are in two different planes. And then finally, parallel planes. Parallel planes are planes that do not intersect. And we've got a picture of that down at the bottom, plane A and plane B. Let's take a moment now, excuse me, and look at an example. All right, you guys okay if I go to the next screen? Okay. Identify each of the following using the cube shown. Assume lines and planes that appear to be parallel or perpendicular are parallel or perpendicular, respectively. We want to name all the lines that are skew to line BC. BC is this back here. So skew means not in the same plane, but also not intersecting. And I've got a cube right here to help us kind of visualize this. So BC would be this back here. I want all of the same, or all of the lines that do not intersect with this, but are not in the same plane. What did you say? So GH, I like that. It is down at the bottom. The problem is that BC is this one right here in the back. and GH, if I turn the cube around, GH is this one right here. They are part of this same back plane together. They don't intersect, but they are part of the same plane because they're both part of the back. Yes. You said FD? FE. Yes. FE. Line FE. Thank you, Jared. FE does not touch BC. Which one? AF. Yes. AF. Okay, so we've talked about this one. That does not intersect and it's part of a different plane. We have this one. Does not intersect, part of a different plane. Can you guys find another one? EH. EH, this one right here, yep. EH, could I call that HE? Yes, EH or HE would work. What else? DE. DE, what else? We've got this one. Which one? GE. So GE, they don't have a line drawn in there, but if there was a line drawn there, yes. If I connected those two dots, if that was drawn in the picture, that would be skew. So yes, you're looking at the right thing. BF. Hold on just a second. I've got too many lines drawn on my picture. I'm having trouble seeing the letters. So the problem with BF is that it intersects BC right here. And I've heard several people say other things, and if I haven't heard yours or if I haven't mentioned it, I apologize. That doesn't mean that you're wrong. It just means that I didn't hear it completely. What else? What else? FG, this one right here. Put my line notation over the top. Okay, so we have FG, we have DE, we have EH, we have AF, we have FE. I like it. I think we got all of the ones that are non-coplanar and do not intersect. All right, part B, all the lines that are parallel to EH. So let me highlight EH. EH, this one right here. Parallel means it has to be part of the same plane. Part of the same plane. So what would be parallel to EH? DC would be parallel. DC or CD. What else? AF, this one right here. So AF doesn't go the same direction. Parallel lines not only never touch, they're in the same plane, so you'll see them go the same direction. FG, yes. FG. This one right here. FG. Now, if I took a plane and I sliced diagonally through the cube, if I took a plane and I sliced diagonally through the cube, does AB go the same direction as FH? So if they were in the same plane, then AB would be parallel. Let me show you on our cube here. So the one that we're looking at, EH, is this right here. And AB is this one right here. So they go the same direction. They're pointing the same way. They're just not part of the same plane. All planes parallel to plane DCH. Let's highlight plane DCH. D, C, H. So this plane over here. In order to be parallel, it cannot touch it. In order to be parallel, it cannot touch it. So we're talking about this side right here. BAF. This side over here would be parallel. That's the only other plane that does not touch the left-hand side. So plane BAF. We're saying that this one over here is parallel. Is there another name that you can give to that same plane? Other than BAF? FAB. Anything else? ABG. Yep, you could call it ABG or GFA. You need 3 of the 4 letters that are right here to name this plane. Any 3 of those 4 letters. All right, let's flip over to page 2. Flip over to page 2. A line that intersects 2 or more lines in a plane at different points is called a transversal. Intersects 2 or more lines is a transversal. In the diagram, line T is a transversal. It is the transversal of lines Q and R. So this line right here is a transversal. Notice we have 2 different points of intersection here. Two different intersection points. This is how, when I'm looking at my picture, I can figure out which one of these 3 lines is the transversal. The transversal will be crossing or intersecting at least 2 other lines. This line here, line Q, only has 1 point of intersection on it. This line here, line R, only has 1 point of intersection on it. But line T crosses here and here. So that is my transversal. Wait until everybody gets this before I change to a new slide. We're going to talk about the new special angle pairs next. So we've had to learn how to recognize vertical angles. We've had to learn how to recognize linear pairs. If you're still struggling with those, please come and see me, because those are 2 absolutely essential special angle pairs, and we don't want to get those confused with our new angle pairs. All right. Transversal angle pair relationships. There are 4 interior angles. They lie in the region between lines Q and R. So angles 3, 4, 5, and 6. 3, 4, 5, and 6 are all interior angles. Interior angles are going to be between my 2 lines. Those are my interior angles. And then we have exterior angles. These are ones that are not between my two lines being cut by the transversal. This is the exterior. Consecutive interior angles. Consecutive interior angles are angles that are on the same side of the transversal, and they are interior. So if I'm looking at just the interior angles, I wouldn't be looking out here, and I wouldn't be looking out here because those are exteriors. Same side interior angles would be like angle 4 and angle 5. They're on the left side of the transversal, and they are interior. Do you guys see those? Left side of the transversal and in between these two lines. Can you give me another pair of consecutive or same side interior angles? 3 and 6, absolutely. These are on the right-hand side of the transversal, but in between the two lines. Perfect. All right, I'm going to erase my drawing on here right now. I do want you guys to write down here that these are same side interior angles. Same side interior angles. And then we have alternate interior angles next. Alternate interior angles. These are non-adjacent angles that are in the interior that lie on opposite sides of the transversal. So again, we're just looking at the interior angles. So I'm not looking at these. It says they're non-adjacent, so they can't be side by side. What's the name for the special angle pair for 3 and 4? That's a linear pair. My alternate interior angles are not a linear pair. If it's a linear pair, it's a linear pair. There's no other name for it. When we say alternate interior angles, angle 4 is on the left side of the transversal. On the opposite side of the transversal, but not touching angle 4, is angle 6. These are alternate interior angles. Alternate interior angles are on opposite sides of the transversal, so one's on the left and one's on the right, but they're non-adjacent. They're not touching. This angle touches angle 3, but this angle does not touch angle 6. Does that make sense? Like the transversal connects them, yes, but they're not side by side. They're not adjacent like this. Can you give me another pair of alternate interior angles? 3 and 5 would also be alternate interior angles. Perfect. All right, so 3 and 5, 4 and 6. All right. These are my opposite side interior angles. Alternate exterior angles. Alternate exterior angles. Kind of like alternate interior angles, except do I find them between the two lines? Do I find these between the two lines? No, because they're exterior. They're non-adjacent exterior angles that lie on opposite sides of the transversal. So now I'm not looking at any of the stuff in here. Not paying attention to this for my alternate exterior angles. Angle 1 is on the left. What do we call angle 1 and angle 2? That's a linear pair, side by side linear pair. So these are not alternate exterior angles. For an alternate exterior angle, I need one on the left, the other one on the right, but not touching. So it can't be this one. It has to be this one down here. Angle 1 and angle 7 are alternate exterior angles. Could you give me another pair of alternate exterior angles? 2 and 8. Perfect. Perfect, perfect. Opposite side exterior angles. Opposite side exterior angles. Corresponding angles. Corresponding angles. Let me find a new color for this one. Let's do pink. Corresponding angles lie on the same side of the transversal and on the same side of their respective lines. I call these my matching corners. You will have one exterior angle and one interior angle. So to find corresponding corners, corresponding angles, matching corners, I'm going to look at the two intersections on the transversal. When I look at the top intersection, there's upper left and lower left, upper right and lower right. Do you guys see those four corners? And then down below I have an upper left and lower left, upper right and lower right. My corresponding angles have to be in the matching corners here. So angle 1, this one right here, is in the upper left corner. When I go to the other intersection, what's in the upper left corner? 5. Angle 1 and angle 5 are corresponding angles. Angle 1 and angle 5 are corresponding. Upper left, upper left. Could you give me another pair of corresponding angles? 2 and 6, upper right and upper right. Could you give me another pair of corresponding angles? 4 and 8, lower left, lower left. Can you give me one more pair of corresponding angles? 3 and 7, lower right and lower right. We look at each of these intersections and we look at the 4 corners made and we match those corners. So far, so good? Please let me know. There is one more type of angle pair that is not on this page that we're going to add off to the side in the margin. These are consecutive exterior angles. Consecutive exterior angles. So they are on the same side of the transversal. Let's see if we can name some consecutive exterior angles. So if it's an exterior angle, I am not looking in between the two lines. We're looking at just the outside pieces. Yes. 1 and 8. Yes. Angle 1 and angle 8. They're both on the left side of the transversal, and they are exterior angles. Could you give me another pair that is consecutive exterior angles? 2 and 7. Angle 2 and angle 7. I love it. Love it, love it, love it. All right. So now that we've learned about these special angle pairs, let's see if we can practice identifying some in a different picture. You guys okay if I go down to the next problem? All right, I don't want to lose anybody. Classify the relationship between each pair of angles as alternate interior, alternate exterior, corresponding, consecutive interior, or consecutive exterior. Part A says we want to look at angle 4 and angle 5. First of all, are those interior angles or exterior angles? Interior angles. Same side or opposite sides of the transversal? Opposite. So these would be alternate interior angles. Alternate interior angles. All right, let's look at a new pair. I have angle 3 and angle 7. Are those interior angles, exterior angles, or one of each? One of each. When I get one of each, I know it's not going to be alternate interior or alternate exterior. I know it's not going to be consecutive interior or consecutive exterior. If I eliminate all of those, what's left? Corresponding. Notice this point of intersection. Angle 3 is in which corner? Angle 3 is in which corner? Bottom left, yes. So angle 3 is in the lower left corner. When I look at the other intersection, where's angle 7? Bottom left, yes. This one is also lower left. So we have matching corners. That means these are corresponding angles. Matching corners is corresponding angles. All right, then we have angle 3 and angle 5, interior or exterior, or one of each. Interior. Same side or opposite sides of the transversal? Same side. What's the C word that we have that means same side? Consecutive. These are consecutive interior angles. Consecutive interior angles. And then finally, we have angle 1 and angle 8. Interior, exterior, or one of each? These are exterior. Angle 1 is above my transversal, and this line is my top, sorry, not above my transversal, above my line being cut by the transversal, and 8 is below this line being cut by the transversal. These are exterior angles. Same side or opposite sides? Opposite. What do we call opposite side angles? Yes, these would be alternate exterior angles. Alternate exterior angles. Fantastic. All right, let's flip over to page 3. Problem number 3, identify the transversal connecting each pair of angles in the picture, then classify the relationship between each pair of angles. the transversal connecting angle 1 and angle 8. So here's angle 1 and here's angle 8. What line do they both touch? F. So the transversal is F. If the transversal is F, then we have 2 points of intersection here. Are angle 1 and angle 8 between these two lines, so they're interior, outside these two lines, so they're exterior, or one of each? One of each. Are they in matching corners? What do we call matching corner angles? Corresponding. 1 and 8 are corresponding angles. All right. Oh, I have the wrong slide. You have different things on here, right? Does it say 1 and 8, 1 and 8, 1 and 8, 1 and 8 all the way down? Okay, so mine does. Mine has a mistake. In part B, yours says angle what and angle what? Angle 3 and angle 6. I don't know why my slide is different, but it is, so we'll live with it. Angle 3 is up here. Angle 6 is over here. What is the line that connects those two? G. So if G is my transversal, then these are the two lines that it's crossing. Are 3 and 6 in between, outside, or one of each? Outside. What do we call outside angles? Exterior. Same side or opposite sides of G? Opposite. So what would we call them? Alternate exterior angles. Alternate exterior angles. All right, what angles do you have for C on your paper? You said 6 and 7? Angle 6 and angle 7. Yes. What is the transversal that both of these angles touch? E. They both touch E. So E is the transversal. If E is my transversal, then these are the two lines that it's crossing. And I want to know, are 6 and 7 in between, outside, or one of each, these two lines? Outside of these two lines?
Oh, it is.
Yeah, it's in between. Here's my transversal, and so these are the two lines that I look to see. Is it in between or outside of? Inside, same side or opposite sides of the transversal? Same. So what do we call those? What do we call same side angles? Consecutive. So these would be consecutive interior or exterior? Interior. Consecutive interior angles. Last one on this problem. What angles do you have here? 1 and 3. So I have angle 1 and angle 3. Let's go highlight those two angles. Angle 1 here, angle 3 over here. What is the transversal that connects those two? D. So if D is the transversal, then F and G are the two lines that I would want to look in between and outside of to determine interior or exterior. Are 1 and 3 interior to lines F and G, exterior to lines F and G, or one of each? Exterior on the outside. Same side or opposite sides of the transversal? They're both on the top. This is above. This one is also above. So they're on the same side of the transversal, but they are outside of these two lines. Consecutive exterior angles, yes. Consecutive exterior angles. All right, we're going to go down to the next section, and that is probably where we will cut off for the day. But we're going to finish out page 3. Now, when I have these special angle pairs and a transversal that cuts 2 parallel lines, so if 2 lines are parallel and are cut by a transversal, then there are special relationships in the angle pairs formed by the lines. Special relationships in the angle pairs formed by the lines. All right. Corresponding angles. Corresponding angles are congruent. The corresponding angles theorem says if 2 parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. Alternate interior angles. Alternate interior angles are also congruent. Theorem 315, called the alternate interior angles theorem. If 2 parallel lines are cut by a transversal, then each pair of alternate interior angles is congruent. Consecutive interior angles are supplementary. Supplementary. If 2 parallel lines are cut by a transversal, then each pair of consecutive interior angles is supplementary. Alternate exterior angles. We are back to congruent. Alternate exterior angles are congruent. If 2 parallel lines are cut by a transversal, then each pair of alternate exterior angles is congruent. Then we have to add this one. Consecutive exterior angles are supplementary. Consecutive exterior angles are supplementary. And then this is down at the bottom of my screen, but it's on the top of your next page. If you flip over to the very tippy top of page 4, it says a special relationship also exists when the transversal of 2 parallel lines is a perpendicular line. In a plane, if a line is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. So if I have 2 lines like this, and we put little arrows on these lines to show that they are parallel. Little arrows go on the lines to show that they're parallel. If those are cut by a transversal and it's perpendicular to one of those parallel lines, then you are guaranteed that it is automatically perpendicular to the other parallel line. So if I have 2 or more parallel lines and a transversal that cuts them that is perpendicular to one of my parallels, it will be perpendicular to all of the parallels. Right. That is where we are going to stop for today. I'm going to be able to pass back your test briefly so that you can see how you did on those. I've got a couple people that haven't taken it yet that I'm going to have to ask to step into the hallway. First homework is due on Tuesday. Homework is due on Tuesday.